So we need to find the derivative of cosine inverse of 2x multiplied to square root of 1 minus x squared with respect to x. So let's begin. So here we will begin by considering y to be equals to cosine inverse of 2x multiplied to square root of 1 minus x squared. Now our task will be, before taking the derivative, will be to simplify the inverse trigonometric function by making a trig substitution. Now, what kind of substitution that we do is going to depend on this particular radical. So here we have 1 minus x squared within the square root, or within the radical, and we know that if we take, in place of x, if we take sine theta or cosine theta, whatever value we take, then we'll have 1 minus sine squared theta, and this becomes equals to cosine squared theta. And once it becomes a perfect square, then taking its square root will become extremely easy. So in our case, what we'll do, we will consider x to be equals to cosine theta. So let's take x to be equals to cosine theta such that our expression 2x multiplied to square root of 1 minus x squared, that this becomes equals to, we have 2 times cosine of theta multiplied to square root of 1 minus cosine squared theta. Now 1 minus cosine squared theta, that will be sine squared theta. So we have square root of sine squared theta. Now sine square of theta being a perfect square, it will become easy to get rid of the square root. That means we have 2 times cosine of theta multiplied to sine theta. And in doing so, we immediately obtain an identity. This identity is actually sine of 2 theta. So whenever we have sine of 2 theta, it becomes equals to 2 times cosine theta times sine theta. So that means our expression y, it can be now expressed as cosine inverse of sine of 2 theta. However, we want to get rid of this inverse cosine function. For that, this should be also a cosine function, but we have a sine function, which is not a big issue. We will make use of the fact that cosine of pi over 2 minus theta will be equals to sine theta. That means if we have sine 2 theta, we can replace it with cosine inverse of cosine of pi over 2 minus 2 theta. That means cosine inverse of cos will go away to give us pi over 2 minus 2 theta. So this is the value of y. This is now the simplified form of y. What we'll do, we'll replace the value of theta and write it in terms of x. So we are given x equals to cosine. We assume x to be equals to cosine of theta, which would mean that theta will be equals to cosine inverse of x. And that means we'll have y equals to pi over 2 minus 2 times cosine inverse of x. Now that means our given original expression, cosine inverse of 2x multiplied to square root of 1 minus x squared, this is equivalent to pi over 2 minus 2 times cosine inverse of x. However, finding the derivative of this particular expression will be way easier. So let's do that. I will take the derivative on both sides with respect to x, which will be equals to derivative with respect to x of the constant pi over 2 minus 2 times derivative with respect to x of the sine inverse of x. The pi over 2 being a constant, so this will become 0. We have negative 2 multiplied to derivative of the inverse cosine function, which has a standard value of negative 1 divided by square root of 1 minus x squared. That means we finally obtain 2 divided by square root of 1 minus x squared. So this is going to be the derivative or to respect to x of our given function, which is cosine inverse of 2x times cosine inverse of 2x multiplied to square root of 1 minus x squared. Right. This is the final value. Now let's move on to the next problem. We need to differentiate cosine inverse of square root of 1 plus x over 2 with respect to x. We will begin by considering y to be equals to cosine inverse of square root of 1 plus x divided by 2. Our task will be to find out derivative of y with respect to x. So let's label this as equation number 1. We'll make a trigonometric transformation to reduce this inverse trigonometric function on the right hand side of equation 1. Let's take x to be equals to cosine of theta such that square root of 1 plus x divided by 2, so this will become equals to 1 plus cosine of theta divided by 2. Now we know there's an identity cosine of theta which is given by 2 times cosine squared theta over 2 minus 1, and from here if we have 1 plus cosine of theta, that will be simply equals to 2 times cosine squared theta over 2. Right. So that means we have, in place of 1 plus cosine theta in the numerator, we can rewrite it as 2 times cosine squared theta over 2, whole divided by 2. So the 2 and 2 cancels out. That leaves us with square root of cosine squared theta over 2. And that will be equals to cosine of theta over 2. So that means whenever we take the trigonometric transformation x equals to cosine of theta, then square root of 1 plus x over 2 will become equals to cosine of theta over 2. So that means equation 1 now becomes y equals to cosine inverse of cosine of theta over 2. So cosine inverse of cosine theta over 2 will be simply equals to theta over 2. Now we took x to be equals to cosine theta. That would mean that theta must be equals to cosine inverse of x. So we'll replace theta with cosine inverse of x. This will give y to be equals to half times cosine inverse of x. Now we have obtained a simplified form of equation number 1. So let's call it number 2. So we will take the derivative on both sides of equation number 2 with respect to x. So that means number 2 follows that we have derivative of y with respect to x, which will be equals to half is a constant multiplied to derivative with respect to x of cosine inverse of x. Right. So this will be equals to half times the derivative of the inverse cosine function. So that's a standard form, negative 1 over square root of 1 minus x squared. Now finally, we can say that the derivative of y with respect to x will be equals to negative 1 divided by 2 times square root of 1 minus x squared. This is the final value. Let's move on to the next problem. So here we have to take the derivative of the inverse sine of square root of 1 minus x over 2. We'll begin by considering y to be equals to sine inverse of square root of 1 minus x divided by 2. Here we're going to make the transformation x to be equals to cosine of theta such that square root of 1 minus x over 2 that will be equals to square root of 1 minus cosine of theta divided by 2. Now we know that cosine of theta that can be also expressed as 1 minus 2 times sine squared theta over 2. So if we rearrange the terms, we can find out 1 minus cosine theta, which will be given by 2 times sine squared theta over 2. So that means our expression now becomes square root of 2 times sine squared theta over 2 divided by 2. So the 2 and 2 gets cancelled out and we have square root of sine squared theta over 2, which will be equals to simply sine of theta over 2. So that means we can rewrite, if this is equation number 1, then equation number 1 becomes y equals to sine inverse of sine of theta over 2. Now sine inverse of sine theta over 2, that means we have half of theta. And since we consider x to be equals to cosine theta, that would mean that theta will be equals to cosine inverse of x, such that y is half multiplied to cosine inverse of x. That does be equation number 2. That means we started out with equation number 1 and sine inverse of square root of 1 minus x over 2 is equivalent to half cosine inverse of x if we make the transformation x equals to cosine theta. Now what we'll do, we'll take equation number 2 and find out the derivative on both sides with respect to x, which will be equals to half times derivative with respect to x of the cosine inverse of x, which is half multiplied to negative 1 divided by square root of 1 minus x squared, or simply put, we have negative 1 divided by 2 times square root of 1 minus x squared. Now this is going to be the derivative of our given function with respect to x. Let's move on to the next problem. Here we have to take the derivative of sine inverse of square root of 1 minus x squared with respect to x. So let's begin by supposing y to be equals to sine inverse of square root of 1 minus x squared. Let this be equation number 1. Here we will make a trigonometric substitution, x to be equals to cosine of theta, such that square root of 1 minus x squared becomes equals to square root of 1 minus cosine squared theta. Now we know that 1 minus cosine squared theta, that's simply sine squared theta, which will be sine theta. That means equation 1 becomes y equals to sine inverse of sine theta. That means y will be equals to simply theta, and since we considered x to be equals to cosine of theta, that would mean theta will be equals to cosine inverse of x. Or simply put, y is equals to cosine inverse of x. Let this be equation number 2. The 1 and 2 are equivalent to each other. Whenever we make the transformation, x equals to cosine of theta. Now what we'll do, we'll take equation number 2 and then we'll take the derivative on both sides with respect to x. So we have dy over dx equals to derivative with respect to x of cosine inverse of x, which is a standard formula, -1 divided by square root of 1 minus x squared. So this was the final answer. Now let's move on to the next problem. So here we have to differentiate the inverse tangent function. So let's begin by considering y to be equals to tangent inverse of x divided by square root of a squared minus x squared. Now our task will be to find out the derivative with respect to x, but before that we will make a trigonometric transformation so that tangent inverse of x over a square root of a squared minus a squared reduces to a simpler form. So here we will make the substitution x to be equals to a sine theta. Now whenever we make this substitution, then our expression x divided by square root of a squared minus x squared, so this will become, in place of x we have a times sine theta divided by square root of a squared minus, so we have x squared, which will become a squared sine squared theta, which will be equals to a times sine theta. So if we take a squared as the common factor within the radical, then we have a squared multiplied to 1 minus sine squared theta. Now we know the 1 minus sine squared theta, that's simply cosine squared theta. So we have a times sine theta, which will be divided by square root of a squared times cosine squared theta. So that gives us a times sine theta divided by, so we'll take the square root of the perfect square, which gives us a times cosine theta. This is simply cosine theta. So a and a gets cancelled out. Sine over cosine, that's the ratio, which is tangent of theta. So that means equation number 1 now becomes y equals to tangent inverse of tangent of theta. Now tangent inverse of tangent of theta, so that's simply theta. Now we have taken x to be equals to sine theta, which would mean that theta must be equals to sine inverse of x over a. So that means our y is now given in the simplified form as sine inverse of x over a. So let this be equation number 2. So we have simplified equation number 1 to equation number 2. Now our goal will be to take the derivative on both sides of 2 with respect to x. So let's do that. So we'll have dy over dx, that will be equals to derivative with respect to x of inverse sine of x over a. Let's find the value. Now we know that inverse sine function, the derivative will be given by 1 over square root of 1 minus x squared. So here x is given by x over a whole squared, but we'll need to apply the chain rule. So this will get multiplied to derivative with respect to x of x over a. So that gives us 1 divided by square root of a squared minus x squared divided by a squared. So this was multiplied to 1 over a, which is a constant, multiplied to derivative with respect to x of x. Further simplification will give us a divided by square root of a squared minus x squared multiplied to 1 over a times 1 derivative of x with respect to x. So that's 1. That is a and a gets cancelled out, leaving a factor of 1 in the numerator, and therefore we can say that derivative of y with respect to x will be 1 divided by square root of a squared minus x squared. Right. So this is the value. Now let's do a final problem. So let's begin. We will consider y to be equals to sine inverse of x divided by square root of a squared plus x squared. Let this be equation number 1. Here we're going to make a trigonometric substitution. We'll consider x to be equals to a times tangent of theta, such that x divided by square root of a squared plus x squared, this will become, we have x which will be a times tangent of theta whole thing divided by square root of a squared plus x squared. So x squared is a squared tangent squared theta. So this will be a times tangent of theta divided by square root of, we have a squared multiplied to 1 plus tangent squared theta. So this gives us a times tangent of theta divided by square root of a squared times the 1 plus tangent of squared theta. Now this is an identity which is secant squared theta. Fine. Now we have a times tangent of theta divided by a times secant of theta. So here a and a gets cancelled out. So tangent of theta, we can convert it to its ratio of sine and cosine. So we have sine theta over cosine theta multiplied to 1 over secant theta. We know that the product cosine theta on secant theta, that's 1. So this will give us equals to sine theta. Right. Now that we have sine theta, what we can do, we can rewrite equation number 1 as equivalent to y equals to sine inverse of sine theta. Right. This gives us y equals to theta, and since we consider x equals to a times tangent of theta, so theta must be equals to tangent inverse of x over a, and our y becomes equals to, so theta, that will be tangent inverse of x over a. So our goal will be to find out the derivative of dy. That means we'll take the derivative with respect to x on both sides to get derivative with respect to x of tangent inverse of x over a. The derivative of the inverse tangent function, that's given by 1 divided by 1 plus x over a whole squared multiplied to derivative with respect to x of x over a. So here we have used the chain rule. So this will give us a squared divided by a squared plus x squared. So this will be multiplied to 1 over a, which is a constant and is taken out of the derivative. This will be multiplied to derivative of x with respect to x. So here 1a from the denominator, 1 from the numerator goes away, and that leaves us with a divided by a squared plus x squared multiplied to derivative of x with respect to x is 1. Hence we can say that our derivative with respect to x of the original function, which is sine inverse of x divided by square root of x squared plus a squared, so this has a value of a divided by a squared plus x squared. So this is the final value.